Hi everyone, I'm Oracle. You may have heard much praise about LSP, or Language Server Protocol, which makes programming easier by features like better auto-completion and definition lookup. For example, when you are writing a Python program and you want to replace a string, but you can't remember what the function signature is, or you want to jump to the definition of a symbol in the standard libraries, LSP is really handy for this. Nowadays, almost all IDEs have this feature built in. As an Emacs user, you may have been longing for this feature for a long time. Emacs has mainly two LSP clients out there, egrot and LSP mode. Egrot is lightweight and it could almost run out of the box. So in this video, I'm going to show you how to set up egrot and demonstrate LSP features with a Scrapy project. And here is the agenda of this video. I will go over my config briefly, demonstrate the main features, and then a bonus feature in the end. So don't move away and keep watching. Before diving in, I want to walk you through the window layout briefly. The left is the main window, where I will write code and interact with Emacs, and this top right window is for key casting, so that you can see what I'm typing exactly, and the bottom right window is a terminal for running command line programs. First, let's take a look at the config. I make it minimal so you guys can try it without much effort, and I will put it in the video description below. The beginning part is to load a beautiful theme and increase the font size for a better watching experience. And the next part is to install the package manager, and then load KeyCast from a local Git repo and customize it a little bit. And org mode for the agenda, and then comes our hero egrot. Install egrot, install a company package for better auto-completion, and disable the multi-line echo of LDoc by setting this variable to new. If you don't do that, the height of the echo area will change frequently and distract you. And then define a few key bindings for egrot related package to save typing. And then I install PyVam for using a dedicated virtual environment Devo, where I've installed a Python language server and Scrapy, a framework to scrape websites. At last, I define a command and key binding to show the topic. Now let's look at the auto-completion. First, I have to create a demo project of Scrapy. That's it, but egrot can recognize it as a project at this stage. The easiest way is to initialize it as a Git repo, like this. Now open the spider file in Emacs. Scrapy has already prepared us the skeleton. There's a import and a spider class. And we can enable egrot by typing metax egrot. Since I have installed more than one language servers in this virtual environment, I need to choose one of them. tap to do the completion. Here I will choose PYLS. And wait a moment and it will prompt us that it is connected. Now I'm going to delete this import Scrapy statement, then type it myself. Typing known white space characters will trigger the company mode to start completing, so type S and wait for a short delay. Scrapy. If company doesn't prompt the completion automatically, we can also do it manually by typing meta x company complete. Yes, we can see that now there is a list of candidates here. We can navigate the items in the company menu just like in a normal buffer. Type Ctrl N to move to the next item and Ctrl P to brief item, and Ctrl V to scroll down, and Meta V to scroll up. When we find the right one, hit enter to select it. Here we just choose Scrapy. If there are too many items to navigate, searching is a better way. Let's take a string object as an example. We can see that there are a few dozen candidates here, so type Ctrl S to stop searching, and then type the keywords that we want to search. For example, type F. The matched items will be highlighted in yellow. Then type Ctrl S or Ctrl R to loop over the match results forward or backward, just like in a normal buffer. Sometimes we may want to do auto-completion when there is not any known white space characters at a point. For example, in the import statement, we may type import space and then hesitate for a module name. In this case, we can type meta company complete or Ctrl-C tab in my key bindings. Equal will show us a list of candidates of modules. That's how auto-completion works for import. Let's keep trying and see how auto-completion works in other places. In the class definition, delete the superclass and then type Scrapy dot and wait for a moment. Yes, we can see that it works here. Spider. And what about inside a function body? Let's define a full method and play with a string instance. And then type message dot and wait for equal to list our methods. And we can see that there is plenty of candidates for string methods. So yes, it also works here. Let's pretend that we want to replace some characters in the message. Type message.rep. And we can see that company automatically indicate that there is only one candidate here, so we just type tab to complete it. In case we forget the function signature, we can see that Igor has nicely shown it in the echo area at the bottom, so we can be sure how to fill in the arguments. If the outdoor content can fit into one line of the echo area, we can split a dedicated buffer to show the docs by typing Ctrl+X dot. The magic here is that if we move the point to other symbols, the outdoor buffer will update accordingly, just like this. You may want to close the outdoor buffer at some point, as it takes too much space of the screen. Delete it by typing Ctrl+X1. And when you need it again, summon it by typing Ctrl+H dot. Well, that's auto completion and function signature hints. It's common that there are syntax errors or style problems while we are coding. In this section, let's see how to fix these issues in Igor using FlyMake, a built-in package of Emacs. While writing code, Igor synchronizes the code with the language server on the fly. When there are problems or diagnostics in FlyMake's terms, the language server will notify Igor to mark the problematic code with wave underlines, taking advantage of FlyMake. There are basically two types of diagnostics, one for errors in red underlines and another for warning in blue underlines. Let's try to make some errors. FlyMake mainly provides two commands to navigate these diagnostics: FlyMake go to next error and FlyMake go to brief error. Here I will use key bindings to invoke them. As we can see now, there are a few FlyMake diagnostics in the buffer, as we can see from the wave underlines. Now type Ctrl+C+F+P to go to the first error, and we will see that Igor will describe the details in the echo area. So for this import statement, it's because the ABC package is imported but unused, so we just delete it. Then move on to next error. Fixing the issue is a piece of cake. Following the diagnostics, make sure that they are all eliminated. We spend way more time reading code than writing code as software engineers. On one hand, Igor provides many features to help us write code more efficiently. On the other hand, it could also help us quickly inspect the code by looking up definitions and references based on the built-in mechanism xref. There are mainly three commands: xref find definitions, xref pop marker stack, and xref find references. For example, if we want to pick the definition of the superclass of Scrapy.spider, move the point to it and type meta dot. An egrot will instantly open the file and head to that class in the current buffer. When done with the code, type meta comma to jump back. In other cases, we may want to find all references of a function. Type meta question mark and egrot will list the references in a dedicated buffer called xref. Let's make this full method called self.pass. And another bar method also calls pass. Now move the cursor to pass and then type meta question mark. See, egrot will list the references in this dedicated buffer. We can click on each item to see the context. Or if you prefer the keyboard over the mouse, you can type meta G N to go to the next item, or meta G P to go to the previous item, just like this. Parallelly xref buffer by typing Ctrl X1. A little surprise egrot gives us here is that it provides references regarding context. So for example, if we define a variable name in two functions, and then find the references for name in one of the functions, it will only show us the references in this bar function. Nice. Auto-completion, function signature hints, fixing errors, and finding definitions and references are almost the fundamentals of LSP. But in the end, I want to show you another sweet feature, egrot rename. It's really handy when it comes to refactoring. As many of you may know, a cur and wgrep help us refactor code, but sometimes we need to exclude the false positives as it isn't aware of the context is line-oriented. LSP can shine here as the language server will give egrot the suggestions based on context so that egrot rename can rename symbols correctly. For example, let's define the same variable name as we already did and reference this name in a formatted string. And then we will try to refactor this name variable to something else. Move the point to it and then type Ctrl ER, which I have binded to egrot rename. In the mini buffer, we can type meta n to load in the current name and then tweak it a bit. Let's type the new name, say name underscore new. we can see the equal renames here correctly. The symbols in the literal string is not changed, nor are the variables outside the function foo. But I'm not sure how robust it is. It depends both on eGrot and the language server. So in case it works unexpectedly, don't panic. We can still fall back to our good old friend occur and wgrep. That's it for this video. Hit the like button below if it helps. I hope you're coding better and more efficiently with the help of eGrot. Right now, I'm creating more Emacs videos, so stay tuned. Click the subscribe button below so as not to miss any of them. If you have any questions, leave a comment below. I will respond as soon as possible. See you.